CPR is one of the most effective life-saving interventions, yet millions of people hesitate to perform it when it matters most. 9 out of 10 people who experience cardiac arrest outside of a hospital do not survive. With every minute without CPR, a person's chance of survival decreases by 10%.
Let's dive deeper into this issue. Each year, approximately 3.8 million people worldwide experience out-of-hospital cardiac arrests. Over the past 30 years, global deaths from cardiovascular diseases have increased by 60%, with the highest rates concentrated in Europe and Central Asia. Despite the stakes, in a UK survey, fewer than 3 in 10 people felt confident in their ability to deliver CPR. As a result, bystanders often wait for emergency medical services instead of intervening. The impact of this action is clear. Patients who receive bystander CPR have a 28% greater chance of survival and are significantly more likely to heal without severe brain injury.
That is why we are making a CPR assistance device. The primary beneficiaries of our device are everyday bystanders with little to no medical training. This includes students, coworkers, family members, and members of the general public who may be present during a cardiac emergency but feel uncertain about performing CPR.
In rural and underserved communities where emergency response can take significantly longer, timely CPR is crucial. Because of delayed ambulance response times in these regions, the role of a bystander can mean the difference between life and death.
Past solutions are extremely expensive, which makes it difficult to include into ordinary first aid kits, providing a barrier to accessibility for the average person. Furthermore, these other devices often assist users with either only pacing or compression, not both. Thus, we now introduce SafeHeart, a portable, cost-efficient CPR assistance device that provides both timing and depth feedback, two of the most critical components of effective CPR. Our device design prioritizes minimized overall size and price by using simple materials, with the goal of being insertable into everyday first aid kits with printed instructions, ensuring accessibility for all, no matter their experience. Our central design criteria includes having reliable timing and accurate pressure feedback. Research shows as responders perform CPR, they exponentially lose accurate compression performance by each passing minute. This is solved by our stable metronome and LED pressure sensing system to help users maintain steady pacing and proper pressure. SafeHeart solves these issues by being cheaper as a single-use device for emergencies while guiding users in accurate and consistent pacing and pressure performance.
So here's the inner circuit of SafeHeart as a breadboard prototype powered by a 9-volt battery. Here at the top we have a metronome circuit that's centered around an NE 555 timer chip, and currently we have this timer connected in series with about 70k ohm resistance and a 4.7 microfarad capacitor to produce 100 beats per minute that we can change as we increase or decrease resistance. To actually generate sound, we use this speaker to make that beeping sound that will aid our user in keeping proper CPR pace. And then here at the bottom, we have a simple light switch circuit that uses a small 2k ohm resistor in order to turn this green LED light on when the switch is pressed. This switch will be triggered when an external spring has been compressed by the necessary pressure needed for CPR.
The springs are each attached to the external component. As users press down on this button-like device, the springs resist at a load rate of 490 newtons per inch, assuring the correct force has been applied to reach the target 5 cm depth.
Our success in 3D modeling and building a fully functional circuit prototype confirms that our concept is technically viable and capable of providing real-time feedback to users using a simple and low-cost design. However, at this stage, the system has not yet been fully miniaturized or integrated into a single portable device. While our current setup demonstrates core functionality, it is not yet optimized for everyday use in emergency scenarios. We also plan to continue testing and refining our spring mechanism to ensure consistent and sustainable compression force throughout prolonged CPR events. Moving forward, we plan to develop a custom printed circuit board and develop our first fully integrated product prototype. This will improve reliability, portability, and usability, positioning SafeHeart for further testing and real-world deployment.
By empowering everyday people with real-time CPR guidance, SafeHeart has the potential to transform hesitation into action,
turning action into saved lives.